Hello everyone and welcome to a new tutorial on Grasshopper. Um, this time I'm gonna teach you the second tutorial about Volvox. In the previous tutorial I just covered different tools in Volvox, how to install it, how to import information and data into Grasshopper. How to manipulate this, edit, segment, create sections, and export back the cloud, the point cloud. Um, but in this video, I will do something even more interesting, is how we can use Volvox to export a whole 3D model or any model 3D element that we have in Grasshopper and convert that, transform that into a point cloud. And this is very useful if you want to, for example, create your own models as point clouds, export them, and then import them later into Sketchfab. So this is a great opportunity to learn something completely new. It has been very difficult for me to try to find. I was trying to do so. I did some research. There are some other methods, and other people have done fantastic work on this. One of those is a colleague of mine at ETH in Zurich, Philip Ulrich, who has done a fantastic job. He has a Sketchfab channel. He works in Cinema 4D and other software, which is quite sophisticated. I don't know Cinema 4D, so I found an alternative way to do it. So I have here in different layers, I will show you different entities or elements that I created. So I have a mesh. This is a Delano mesh. Remember in the previous tutorial on Volvox, what I did is I just created my own Delano triangulation and mesh from the point cloud. So here you see one with less resolution just to speed up the process, but it's pretty similar. Then I have another mesh extracted that is also very regular. The triangles are different. So this is a perfect, let's say, thin triangular irregular network, while this is more irregular one, completely irregular. As you can see the difference. So the resolutions are different and the level of detail is different. I created the second one using a DTM, a digital terrain model, manipulated with Bison. I have other tutorials in Bison available in my YouTube. Have a look at them. You can do the same with DocoFossor, okay, which is another plugin, and just extract the mesh. I have several meshes. I have also Breps. In this case, are these two cubes that representing buildings that have been embedded somehow in the terrain. Okay, are out of the scale, but are just for the purpose of um, for the purpose of this tutorial. So I have these Breps, and I have another surface that I created as a surface. It's just a simple surface created with a loft. It's a loft surface and created with two curves. Okay, so they're simple, and I'm trying to overlap them to the existing terrain so you can see when we export how they are all together linked somehow in terms of the spatial location. Now, let's imagine you derive this from LiDAR point cloud. The LiDAR has a geolocated position. As soon as you insert it into Grasshopper and Rhino, this position, this geolocation or georeference is lost. And the new reference will be the X, Y, and Z of Grasshopper and Rhino, the new origin. So bear in mind this, if you want to extract something from this and merge it with an existing point cloud which has a geolocation, the entities may not overlap with each other. So you need to find a common way or a workflow that allows you to overlap them. A potential option could be importing all the point clouds using Volvox, align those importations, and whatever you have created, overlap, align perfectly with this imported LiDAR point cloud, and then export all together as a new file. Make sense? So that's an option. Okay. Now, what we're gonna do is we're gonna start with a simple mesh. This is the simplest mesh I created. It doesn't have that much complexity, okay? It's a topography. Exactly like this can be a mesh of a ground surface, could be a city, could be a green open space, whatever, okay? So what we're gonna do is gonna add a mesh in our Grasshopper interface. And then we're gonna use, we're gonna add it, set one mesh, and then we're gonna add this mesh, okay? We need to unlock here, that's the mesh. Then I'm gonna turn off this, so we don't have the overlapping lines on top of our Grasshopper image. You can also internalize it, but that is not, I don't want that. I'll just keep it simple like this, okay? Now we're gonna deconstruct that mesh. Deconstruct mesh. Okay, it's very simple. We just connect, straightforward. So what you got here is for each point, oh, in this case, it's good to turn on. Look, each point of your triangle and the triangulation or the Delano triangular regular network, whatever you, any name you want to use, every vertex of that, it's represented here, is extracted as a vertex, okay? So you have here vertices, faces, vertices, sorry, faces, colors, and normals. Of course, there's no colors, and the normals are there, so are vector. Colors, they are not colors. The faces, you have 4,000 or 5,000 in vertices. Now, what we can do is now we can color this. We can name this as a extract points from mesh. Okay, so sorry, group extract points. What we're doing is just generating points from mesh. So we already have the points. So the next step will be construct cloud. We're gonna construct cloud. And this has been done with, of course, Volvox. So it's here. Construct cloud, or you can drop it. So we add the vertices as points. We can disable everything. So we enable this. Those are the points. Look. Okay. If we have the color information, we add the color information. In this case, we don't have. If we have normals, we add the normals. What we don't add the normals when it's exported, we're not going to have the normals. Okay? Simple like this. Next step, we're going to merge clouds. Okay? If you have multiple clouds, you can merge them. This is very important. Okay? So we merge clouds. If you have multiple clouds, you merge them all here. So I always add it there because if I have another one here, I will add it and will merge it. Otherwise, it will be difficult to export several things. And this will be very useful later. Then once we have this end up cloud, we need is save E57. So you already know this one is save E57, right? This is a different one, of course. Before I have used this save E57 as an instruction for the engine. Now I have the E57 as output. Okay, so I will put the save E57 here. So the first thing we need to for the E57s are the scans, and the scans are the cloud. So you can connect there directly, or you can put also a cloud in the middle, cloud like this in the middle, and connect the cloud and connect to the scans. There's no problem. Now what we're gonna do is define the file path. So I put a file path. And after the file path, I would put a panel. This will help me to identify that my file path is correct. And then I will connect it to the file path. And then I will add a Boolean toggle. You can use just a simple bottom. That's another option because it's very fast when you run it. Look, you can use Boolean toggle or bottom. So the file path, we need to set one file path. So I have here this folder already. So I'm gonna call this, oh sorry. I'm gonna call this, let's imagine we're gonna put make mesh export dot e57. Simple. Mesh export e57. Okay. So here you can read the file path. It's all correct. Mesh export e57. So now I click it. I want to run it. That's it. Simple. It was run. You already exported. Now, how you know? Can be any mesh. Can be a mesh of a terrain, but it can be any mesh you have created in Grasshopper. So now, where it end up? Okay, we need to go to the file, and the mesh is here, mesh export. To visualize it, you can use any software that can open E57. I have CloudCompare, is easier for me, and I go to mesh export, open it. This is my mesh export. As you can see, the point clouds are very sparse. Okay, let me use the EDL. So you don't get that much sense, even if you need to make it very big just to make it visually interesting. But they're very sparse. Okay, but let's imagine you have a mesh with a triangular network much smaller, etc., or the mesh we created in the previous tutorial. Now we can do it with a mesh that is much denser. Okay, let's imagine we're gonna use this one. Okay, so we're gonna replace this mesh, set one mesh, with a new mesh. Okay, now what we're gonna do is turn off this. It's a new mesh. You see the points have changed. There are many more points, and we're gonna export it, and we're gonna change the name. So in the file path, setup, and we call it mesh export 2 dot e57. Become save, and then we run it, and it should be done. So mesh export 2 is there. You see it's 1000 kilobytes, so it's much larger. Now we mesh export 2, and as you can see, the points are much denser from the mesh. So you see they are much a bit denser, but it's not very high density. If you select here the second scan, look, it's only 45,000. The previous one was 2,500. So it's not very dense point cloud. It may look very sparse. So you can modify this. Okay, make it much denser. So what we're gonna do in the next step, we're gonna group all of these, and we call it export E57 cloud. Yeah, that's all. Yeah, we're gonna use it later several times. So now what we can do is export it as a surface. Okay, and we can add we can have a sort of control of the amount of the amount of points. Okay, how to do that? That's the next step. So we have our mesh. We'll copy the same mesh. Okay, but what I'm gonna do is I'm gonna grab all of these and I'm gonna disable. Okay, I'm gonna disable this one as well. I don't want to see it. I want to see only this one now. Again, our regular network, much smaller and fine scale. The number of vertices is much higher. So the number of vertices tells you the number of points if you export it in this method. Okay, now what we're gonna do is again deconstruct mesh. Okay, it's the same pretty much. This time we're gonna deconstruct faces. Deconstruct faces. And in this way we're gonna be able to deconstruct, create our own surface. Okay, so deconstruct faces. Now what we need to is add list item. We use list item to extract the list. So we connect the vertices to the list and the index from corner A. So as you can see, the number of points increased considerably. Okay, let's turn off this. Sorry, I made a mistake again. Is it this one? I should. So as you can see, they are much cluttered, okay, compared to the original one. Okay, this is the first item. We need to do it for the 4 corners. 4. So we connect the B here in the second index, the C in the third index, and the D in the fourth index, but all connect to the vertices, okay? We have 1, 2, 3, and 4. Now what we have to do is create a 4-point surface, because we have the 4 corners, and we connect corner A, B, C, and it's a bit slow. It's taking a bit, and 4. Okay, and we have a surface. So what we're gonna do is, in order to speed up here the representation, just wait for this. Just wait for this. It's taking a bit. Okay, I'm gonna select. No, it's messing up. Okay. Okay, I want to select all of this, and I'm gonna disable them. And I have already the surface. As you can see, it's full of points. The surface that has been created, there is an error here. I don't know, it's very difficult to control for everything, but then we turn it, we disable as well to make it easier for us, okay? So the next step is just to transfer this into surface. Surface. Okay, that's the surface. And that's it. That's our surface. So we don't see the points anymore. Simple. This is our surface, but this surface has much more number of points. Now what we can do here is something is to determine the number of, let's say, points. So there are different options to determine the number of points we want to have in the surface. So one option is divide surface. So we're going to divide the surface. It's going to divide each and every surface. In this case, there are several ones of each of these triangles. Okay. And the second method is surface domain number. Surface domain number. So I think surface domain number is from paneling tools. Okay, so you need to have this. Is from paneling tools, so you need to have this tool also installed. The previous one is from surface, so it's different. Okay, if you have paneling tools, you use the bottom one. If you don't have paneling tools, you use the top one. So in this case, you just connect the surface to the first one. You need to define the UMV. So to make it simple, I will use the same UMV on both directions. Okay. So just thinking a bit because there are a lot of points. So what I'm going to do in order to speed up this process is use the surface that has less number of triangles, because this will be very heavy. So as you can see, this surface can be immediately exported. I will show you how it can be immediately exported and have higher resolution than the previous one, because there are a lot of points here. But just let me change the surface here. Just give me 1 minute. It's taking a bit. Still thinking. So why it took so long? Because the UMV are automatically set to 10. And it took quite a lot of amount of time. If you put 1, let's imagine 0, 1, oh sorry, we should start 1, let's imagine 2, 10. And we connect this to both U and V, it will be much faster. So what I'm going to do is I'm going to disconnect this to speed up the process, connect this to 1 and 2, and equally connect to the grid. Okay, oh, sorry, 1 and 2. So what happened here is, like, when we connect, it will take quite a while. So what I'm going to do is I'm going to change for the other grid. This is the number 2. I'm going to use the number 1. So I'm going to forget about these clear values and right click set one mesh, and it will be this new mesh. I have to unlock here, set, and then turn off this. So what you're gonna get here in this surface, again, let's see, just this, all this was the process only to transform all of this up to here. It's just to transform mesh, or we can put it easier, okay, mesh to surface. Okay, so we have a surface, not a mesh, and this surface can go to this x and y, and you can define the number of the u and v numbers. So as you can see, you can increase the number and it will increase the number of points. Let's put 5. Okay, simple. Now let's go to the exporting. So we copy all this whole script here. Okay, we group it again, and then instead of using the original points, we need to change here the name. We're gonna need to change the file path. So we're gonna call this mesh export. We call it mesh surface export, and we are gonna put okay. Now we are gonna connect the points. I'm gonna avoid putting the normals because there will be too many. And as you can see, it's already taking a while because it's trying to connect, and the normals are just too many. There are just too many points. So let's wait there. As you can check here, is the number of points in a minute. So now it's done. I need to disconnect these normals and disconnect the colors. Okay. So now it's there. It took a while because of the normals. I should have disconnected the normals. So this adds considerable amount of information and time, processing time. So once you have this, we need we change the name already and we run it, and that's it. It's already saved. So we come here and it's mesh surf export, and you see it's 2 kilobytes, and it shouldn't be 2 kilobytes. Look, it's something wrong here. Maybe, I don't know. Maybe it's still saving. It's very weird. Let's see. There is an error maybe here, or not an error at all. So, oh yes, this is an error. Look, it didn't do the properly the saving. So what we can do is let's try it again. Otherwise, let's try the other method. Let's delete this. Let's run it again. And let's see what's going on. Yeah, it's exporting wrongly. So for some reason, this is not working properly. So you need the paneling tools. I don't know why it happens sometimes. So let's disconnect these points here. Now we're disabling this, and then let's enable this one. We need to connect the surface, sorry. So we have here the paneling tools is working properly. We can reduce the number, but let's see what happens when we connect to the points. It should be faster. It's quite fast. And now we do the same and we run it. It should already there. 2 kilobytes again. Maybe there is a problem with the name or something. I don't know. Let's change here the name, the file path. So let's put the name now. 3. It's because it was not properly E57. Okay. Let's call it like that. And then we run it again. No, there is an error again. It's very weird. Let me see what happened here. Okay, now I know what might be happening here. And it didn't happen before in this extract, but I noticed this should be flattened here. Okay, you have the points, that's the error that is generated. So my mistake, you just put attention to this, very important to flatten here. So now the export will be all flattened. Okay, and let's do it again to see how it works. Now it's saving. So now save properly. If you don't flatten, it doesn't assume they're doing the things correctly. Now let's open it. Let's close these ones. Let's open the export tree. So yes, export tree was exported properly. And you can see here the number of points that are for each triangle are 5 by 5. So it's a different type of representation. It look a bit awkward, but it's different. Now let's do something, and let's connect these points, and let's run it as 3B. Okay, we run it. It's saving. It's taking a bit longer, but not too much. Is the 3B is done properly. Let's come again to CloudCompare. Check. Always check your exports. And you can see they are there. Look, it worked perfectly. So the error was there not in the tool, but in the flattening process. Okay, this is all good. Now let's replace this now with the other mesh. I want to see what happened with this other mesh and try to do a very dense point cloud. Yep. So we clear values here. We turn on we turn on this mesh. We set one mesh. And we put enter. So it takes a bit longer because this mesh has more triangles and more complexity than the previous one. So we just need to be a little bit patient because it's going to generate 5 points for each of these triangles. There is approximately 1 meter. Okay, so just let's wait for that to happen. Okay, it's done. So what we're going to do is still thinking. I want to turn off this. So let's turn off this. And you can see the number of points is much denser. So what we're going to do is now we're going to call it this 3Z. 3Z. Okay. So before proceeding, I should flatten this one here as well. Okay. This case didn't happen because the vertices, it just works different, but this one should have the flatten. Okay, remember that. Now what we're gonna do is gonna export it as a 3C, and it's taking longer because the number of points is much denser. Okay. So you can control the size of the triangulation, the size of the mesh for the triangular regular network, the complexity, the regularity by exporting or preparing the mesh before. You can control the number of U and V's, I mean the distribution of elements in the surface, and then exporting everything. Okay, so there are many ways you can control the density. Now let's go to open the mesh 3C. It's 75 megabytes. It's completely different. This is going to look more like a dense point cloud. Of course, this is the effect that we wanted to create. I'm using the EDL, remember, just to show this shading. So let's go closer, closer, closer. Of course, you're still seeing gaps, but that is much more denser. Okay, much dense. The density is appropriate. And then you can color this. You can set edit colors. Notice that it doesn't have RGB, so you can colors, set unique color. Okay, and oh, sorry, I choose the wrong one. This one. Okay, and you can also color. You can also export these and georeference properly in using QGIS, overlay the real color map that you have an aerial image, or you can use a Photoshop image and then recolor each point based on your Photoshop. Okay, so it's the other way. Or you can grab again, and as I show in the previous tutorial, go to scalar fields and generate the height, etc. Okay, So this is working. Okay. This is something I want to turn off, and also this. The more things are on, the more complicated it's becoming. Okay, so the next step will be is what happens if we have a simple surface, or a surface that we have already here. So it's this one. Okay, the surface, it's positioned within the space within the same area of the mesh, just to show when we export from Rhino, everything will be exported using the same position. Okay, origin. So to do an export of a surface is much easier and straightforward. We need to generate points in the surface. So what we can do is we have the surface. So let me add surface. We set one surface. This is the surface. Yeah. Enter. Here we have our surface. What I want to is use the quad quadrangle grid. Can you find it there? It can be quadrangle grid. So this quadrangle grid is again in this is in another set of tools, Launchbox. So you need to have installed Launchbox. Okay, it's another plugin. It's not difficult to install, so it's the same logic that all the plugins. So you have here the surface, connect the surface. You have automatic generation of UMVs, divisions. I will increase it to 250. Increase it, sorry. Go there, go there. So you have a much dense, a dense number of points. Now you see it's quite dense. Okay, that's all good. So what we're gonna do now is gonna do the same here that we did before. We are gonna use a construct cloud from points. So we have coordinate point. So what we can do is just to create a point, sorry, and then add the point there. If we disable, it's much easier for us to manipulate, and the speed up is much faster. Okay, so we come here, we do this, this, and this, and also we need to add the midpoint. Okay, we have 5 points, and then we put here construct cloud. Okay, we construct the cloud again. So what we're gonna do is simply copy this again. Sorry. There. My mistake. This will create a lot of points here. We're gonna disconnect. Okay. So now we're gonna do is put the points, and then we're gonna add all the points. So you put shift, you click shift and add the points to add all the points to this construction of the point. Okay, so you're adding multiple. Oh, that's it. You merged it with this. Okay, all good. Sorry. We're gonna change the name. We're gonna put now it should be surface, right? Surface export. Okay. Now it's a surface where we're exporting, and we click saving. That's the good thing of this. And surface has been exported. And we come here, look at this surface export, and it will export it on top of it. So using the same origin. The color, of course, is completely different. Okay. So now you can merge them. Yes, you can grab here. These and these are always duplicate. Once they're duplicated, are merged. Then generate new color fields now, or just it's up to you. Now it's one single point cloud, but you can also merge them at once here. So let's imagine you have this, and you want to merge it with this cloud. Okay, so you constructed the cloud here, and you have your cloud here. So this cloud, what I will do is I will disconnect here, disconnect, and then I will merge that here in this cloud, in the shift. So here you will have both clouds merged. That's why it's used merge cloud. And I will change the name here to, sorry, the file path. And I will put surface mesh. Instead of export, I will put merge.e57. Okay. Once has been done that, I will run it again and it's saving. It will take a while because there's information from both directions. Okay, let's wait for this to happen. We're saving. Come on. It's taking quite a while. Okay, done. They're merged 82 megabytes. Now let's open it. Merge. So there are 3.5 million in them. They are merged. So what is the difference? Why we should merge it, when we shouldn't merge it? Okay. If you have entities that you want to color separately, you can color them in Rhino and Grasshopper, but I didn't find any way to do it so far. You can explore that, or you can color them here. So what I did before, when you have two separate entities, it's like you can grab this entity. This is the, you can grab this entity and edit the colors and then set a unique color. So let me grab the entity. Is this one. I will choose the color red. Okay. Now I have the other entity, which is light green, or this sort of ground color. Then I duplicate them as usual. I always recommend this, not to mess up with your original files. And then remember that CloudCompare doesn't save your working environment. So if you close this, you lose it. Okay. Or if you mess up, you have to start over again the process. Okay. You have these two, you merge them. You say no. Now they are merged. They have each entity a different color. So it's much easier to color them if they are separated. If they are joined, no, because if you want to set a color, edit color, set unique color, everything will be set one single color. Oh, I made a mistake, sorry. Look, this happened, I set one color, okay? So the merge one, all one color. So if you change the color to this beautiful color, look, in the other case, you have the chance to color each one independently. Let's delete this. Okay. So you can do this for buildings, for example, and color each building independently, or all the set of buildings in one color, all the set of streets in another color. So that's an option. So you can either merge them if you need to merge them, or because you are merging here a mesh, a surface, and you can merge a building. I will show you that later. Let's keep it like this. Let's imagine that we're gonna disconnect all. Okay, we're gonna disconnect. Sorry, disconnect. We can keep it there. That's fine. Let me grab this. Connect it there. Okay, what we're gonna do now is we're gonna create a building. Okay, so this is we can put a name. Generate points on surface. Okay, generate points on surface. Okay. What we can do is generate buildings. So I have some buildings here as Breps. So how you do it with these two boxes, or can be any model. Just be sure there are Breps. Okay. So you have here Breps. We can add them both at the same time. Brep. Okay. Wow, sorry. So I will do something. Brep. So the first Brep is Brep. I will use, again, you need to populate it. Okay, sorry. So this vrep will be my building. So I will set multiple vreps, enter, and then I will turn off this. So I have my vreps there, correct? And then I will color them. I will populate them. So before populating, you have to deconstruct the vrep. Deconstruct vrep. Okay, grab it, connect. Beautiful. You see there are 4 points. If you extract this, if you extract this vrep, will be only 4 points for each one. Sorry, 8 points. The 8 vertices. So you have here faces, edges, vertices, and you have 16 because there are 2, of course, 2 volumes. Can be any vrep. Now what we're going to do is use something called populate 2D to populate the region. If you use populate 3D, it will populate the whole volume. So you will generate points in the middle of not in the surfaces, which is something we don't want, because imagine you have a lot of buildings, you have tons of millions of points in the middle of the building that is something is useless. We don't want that. So we'll use populate 2D, and we connect the faces to the region to define the region. Ooh, beautiful. Okay. And then we just need a count. So we can use 1000, for example, or 500. Let's use 600. And we put that in the count. So it's taking a bit. So what you see here, let me choose this, and then okay, you have the points there. Only on the surfaces, not on the whole volume. And this is very important. So it reduces the amount of points and calculation, computation time. So once you have the population, then again, you run the same sort of. We disconnect, and the points will be this point. Easy peasy. So we changed again our name, and we're gonna put vrep export 1. Okay. Okay, good. So this has been exported. We click, and that's done. So we come here to it should be there, vrep export 1. So you come to the CloudCompare. Let's imagine I have this surface. Okay. Now let's put open vrep export 1. It should be there. Yeah, there are the buildings. You can color separate, but the point is not very dense. But you can create atmospheres. For example, if your VREPs are volumes, you can create an atmosphere. The points can be separated sparse. But I don't want that. Okay, I want much denser. Okay, we use another method. So we don't populate this. And we use another one. So we can call this populate VREP with random points. Okay, it's random. You can use a seed to change the number of points, but anyway. Now, we're going to use something, again, copy this. Can disconnect, let's copy this again, okay, just to make it simple. Same volumes, okay, I'm not changing anything. But I will create a surface domain number again, what I did in the surface before. Remember, surface domain number. No, this is quite weird. Okay, surface domain number, which is this one here. Okay. So the surface are the faces. Oh, beautiful. Then we have ages. We need a UMV again. This can be, for example, 100. Let's use another number to have 90. And we call U, and we call the V, and you see the number is much denser. We create a much better population of the surfaces. So this will be, or you can increase significantly the number of the random points. It's the same. but it will be random. Here are all aligned, perfectly aligned. And now what we'll do is simply I wanna change the name of this group, and we're gonna call populate brep with gridded points. Okay, so when it's done, we just connect this one, and the other one will be disconnected. And then we change the name, and we put, instead of export 1, we will put export 2. Okay, run it. It will take a bit longer. It's done. We go to CloudCompare. We open the export 2. And as you can see, it's much denser, and it's a completely different story. So there are your buildings there. Okay, different story, completely different story. Okay, now if you want to merge everything all together, you just grab this cloud that is flattened, and after you have constructed, and then you plug it here, and then you export the whole cloud, the final cloud. This is when you want all the points together. Okay, so this is other way. So let's do it, because here you have been merging from meshes, but now this is a brep merging with a surface and merging with a surface and merging with a mesh. So what we're gonna do is just grab these point clouds here, put it in the merge. This will be a bit heavier. So save as. We need to change the set only one existing file, and we're gonna call it mesh surface brep 1. Okay, and now we run it. This will take a while because it has many more points, so just wait a little bit. So it has been completed. Let's go there. Should be the last one. Okay, now let's see. This is the moment of surface merge. Sorry, mesh surface brep. Okay, 3.6 million points. There it is. Let me turn off this one. So there it is. So this was the original one. We exported in different, and that's the last one all together. You can export this to, let's say, Sketchfab or any other software. It can be trees, can be other sort of elements that you want to extract. Now, the important thing here, the most important is that whatever you're doing, you try to find the best method for populating the surfaces and converting either using a mesh of a surface. Now, breps are pretty straightforward, and because they are usually help for representing volumes. If you have complex organic shapes that are meshes, there you want to export the mesh directly, like this one. Don't forget to flatten. Or you may want to, in this case, was export directly. But this mesh, it will depend on the number of points. So my logic here is like, let's imagine you have a tree. Okay. And let's imagine you have the ground and a building. So if you have a tree, we can color the tree. Oh, sorry. Okay. Okay. And so for me, the surface of the tree could be a mesh, right? And the mesh has enough complexity by itself. Because the mesh of the tree, let's forget about the trunk. We can delete it, or it can be just a couple of points. If the mesh of the tree is complex enough, there's no point at all to add more divisions in that mesh, or add an UMV. So a UMV repetition. So I will never suggest to do it. So now let's do, for example, a building. So let's imagine the building surface has a completely different color. It is so. For example, for the building, the method of the brep works pretty well. Sorry, um, breps. Okay, for trees that you have already a triangular regular network with enough points, I will populate it maybe with a UAV, depending on how complex is that mesh, how defined the details are not. But if it is complex enough, I will not touch it. But if it needs extra number of points, I will add 1 or 2 points per triangle. The ground could be either a mesh as it is, or could be a mesh, or can be transformed into a surface, mesh to surface. And this is the way I will really tailor the way I'm working in each of these with each of these definitions. So that's, I think, the best way to work if you really want to speed up the process and avoid somehow the problems of overcomputation. Okay, so let me turn on. As you can see, that's the surface. Oh, sorry, I shouldn't have. It's not this one. Okay, it should be this one. Combining all the, as you can see, they're all together here. It doesn't help too much. So, but anyway, these are the different methods to extract. And I hope you find this particular tutorial very useful. You practice at home and you try to represent different surfaces and export. There is another tutorials that I created. I posted before about, for example, how model everything using elk. So I will really would like you to try importing OpenStreetMap data using elk or urbano, generating the models and exporting all the breps as point clouds. So you're generating point clouds from OpenStreetMap, and that will be a very interesting workflow to explore. So this is everything so far for Volvox. There are a couple of other um, tools I still haven't explored that much, but this is for CloudCompare. If you already have CloudCompare, you don't need them, in fact. But basically, this is more of the functionality, or the most important tools that it has. And I really strongly suggest you to try them. They're very innovative. Hopefully, they're running in Rhino 7, and they're working in Rhino 6, even though they were developed for Rhino 5. But give it a try. I should say that there is a disclaimer here. It may not work in your Rhino version. So there are unique factors, many factors that may, or reasons why it's not working. It's working in this case, in this version of this Rhino. I install it and it worked perfectly. Maybe another not. Leave comments if you have issues, and I may try to copy the whole folder or zip the folder and make it available through a Google Drive or Dropbox link, so you can download it and try to install or copy directly the whole folder. Okay, that's all from me, and I welcome you to. I would like you to subscribe. Please subscribe. So there are going to be many more videos in future with new tools and plugins that I'm trying and testing. And so see you next time. Thank you very much. Bye bye.